All right. 961812 October, November 21. When designing computer system, it is important to consider the security, integrity, and privacy of the data. Draw one line from each measure to indicate whether it keeps data secure or protect the integrity of the data. So let us start. So firewall is actually data security. All right. Firewall is data security. A double entry is verification. So data integrity is verification and validation. So this is basically data integrity. Presence check is validation. So remember that data integrity has validation and verification. So whatever that is for validation or verification should go to data integrity. Access right is security. Password is security. Okay, so that is how it works. Now, 2. Complete the truth table for each of the following 2 logic gates. So this is NOR. So this will be 1, 0, 0, 0, exactly opposite of the OR. And this is NAND, which will be 1, 1, 1, and 0. I hope that I don't have to actually tell you how, because this is something. So here this is ON 21 paper 12 9618. Data integrity is the combination of validation and verification. Data security is basically to how to protect the data from online threats, from physical threat, from data, any threat from any reason due to which the data will be leaked. So here, so security is physical security, username, password security, access right security, encryption, decryption security, firewall security, things like that. All right. So now draw logic circuit for the following logic expression. So सबसे अंदर वाला inside bracket A and B. So this is A and B. Then it is not A and B. And C whole not. Okay, so this not is for A and B. This not is for A and B whole not and C. So this is X is equal to. So AB whole not is, since this not is separate, so we will put a separate NOT gate, A and B, and then AND C, and then separate NOT gate. So whenever you have separate NOTs, we will put separate NOT gates. Can we make it NAND? No, that is what I'm telling. Had this been NAND and this being NAND, only then you will be able to use the NAND gate. Otherwise, if it is separate NOT, it means that first you have to carry out the operation and then reverse it. That is why we will use separate NOT gates. Okay. Andy likes to play computer games. Question number 3. Andy likes to play computer games. Andy uses several input devices to play the games. These include keyboard and microphone. Describe the principal operation of microphone. It has a diaphragm or ribbon on top. Incoming voice or sound waves strikes against it and creates vibrations. Which causes a coil to move past a magnet that creates electrical signals. These electrical signals are then sampled by ADC. Okay, so it has a diaphragm, which is also called ribbon on top of it. Incoming sound waves strikes against this diaphragm, against it, and creates vibrations. Vibrations means that diaphragm is connected to a coil. Okay, connected to a coil. Those vibrations move the coil, and in the presence of magnet, that completes and creates electrical signals. All right. These electrical signals are then sampled by ADC. Sir, isn't the coil coiled around the permanent magnet? It is bit loose. Had this been stiff, तो हम vibrations को कैसे read करेंगे? Vibration will never be read then. You have to have it loose so that when vibrations cause the change in motion, that coils moves. Anyways, and he plays some of the computer games over the internet. He has several devices that connect wirelessly to the router in his house. Identify the topology of Andy's home network. Justify your choice. We all have a router at home and with which we all are connected. So this is router and everyone else is connected to the router. This makes it star topology. This makes it star topology. Okay, justification clear. All the devices at home are directly connected to the central router. Okay. All right. The router has wireless access point to allow the devices to connect wirelessly. Identify three functions of the router in ND's network. Okay. Router assigns dynamic IPs to the internal devices maintains IP and MAC table as in the addresses, IP and MAC addresses table. It receives packets from the internet or internal devices forward packets to the destination devices finds the best route over internal network. It applies network address translation for proper packets distribution to and from the internet and internal nodes. Okay. All right. This question was of 3 marks. So you don't have to write 1, 2, 3, 4, 5, 6, whatever 3 point that you can remember, you can write. Sir, क्या router की IPs every time change होती हैं? Acha, routers IPs means 2 things. Either the IP that is allocated by the ISP to us, which in turn is given to the router, and or the IPs which are over the internal network. IP assigned by router. IP assigned by routers, yes, they always are changed because there is a software called DHCP inside the router, Dynamic Host Control Protocol. This particular chip or software inside the router, every time when it assigns the IP, assigns it dynamically until unless you open the setup of the router and assign a MAC address a specific IP. Otherwise, DHCP always assigns dynamic IPs, changing IPs. All right. Question number 4. A register stores the following binary number. The binary value in the register represents unsigned binary integer. If it is unsigned binary integers, this is 205, 128 plus 64, 192 plus 30, 190, 2 plus 8, 200 plus 4, 204 plus 1, 205. Okay. If it is 2's complement, then this 128 is minus 128. In that case, it is 64 plus 32, 96 plus 400 and 101 minus 128 plus 101. So this will be 64, 30, all right, 32 isn't there, sorry. 64 plus 8, 72 plus 4, 76 plus 1, plus 79. This is minus 51. All right. (64) plus 8 plus 4 plus 1. So 77. This is 7751. Yes, minus 51. Oh, minus 51. The binary value in the register represents a hexadecimal number. So if it is hexadecimal number, in that case, we will be taking as 2 hex. So this is 8 plus 4, 12, C. And this is 8 plus 4 plus 1, D. 13. So this is 12, this is 13. C and D. I calculated it wrong because when I did it directly, it was minus 51. And then when I was trying to add, I added it wrong. So I did it directly, it was minus 51. So this is minus 51, minus 128 plus 77. Okay. Sometimes when you do it directly, it becomes easier. When you try to sum up and all, you can commit mistake. At least true for me. State why the value in the register cannot be interpreted as BCD because we have got C and D. So you have to write the denary value in BCD are from 0 to 9, which are represented in 4 bits. Here, 4 bits represent 12 and 13 respectively. That's why. State why the value in the register cannot be interpreted as BCD, because the denary value in BCD are from 0 to 9, which are represented in 4 bits. Here, 4 bits represent 12 and 13 respectively. That is why we cannot represent this particular combination as BCD. Okay. BCD is binary coded decimal. Decimal as in denary, which will never have anything beyond 9 in 4 bits. Okay, the binary contents of 2 registers are these. Add the content of the register 1 and 2. 1 and 1, 2. Remember 1 and 1, 2. This one is sum, this one is carry. 1, 1, 1 is 3. This one is sum, this one is carry. 0 plus 1 is 1. 1 plus 1, 2. 1 plus 0, 1. 1, 1, 1 is 2. So 1 plus 1, 0. 1 carry, 1. 0, 1 carry, 3. 1 carry, 2. 1 carry, 3. 1 carry, 1, 0. So answer is 0, 1, 1, 0. 1, 0, 1, 0. Remember, you get marks for this and this. Okay? You have to remember this, that you get marks for carries and the answer. You should don't try to solve it directly. Okay? So your examiner would like to check your carries as well. Okay. Now, subtract the content of register 2 from register 1. Now, that means, let me first write it down. Register 1, 0, 0, 1, 1, 1, 1, 0, 1. All right. So this is a positive number. Then the second number is this one. 0, 0, 1, 0, 1, 1, 0, 1. So this is a positive number as well. So we have to apply the 2's complement of it so that we could और क्या कह रहे हैं आप सर ओवरफ्लो के केस में क्या करते हैं we will see. I'll discuss it. So first you have to convert it to 2's complement negative. पहले 1 तक same रखना है. We'll keep it same from the right side to the first one and invert the rest. Toggle the rest. So this is negative number. Now we will put this negative number here. 1, 1, 0, 0, 1, 0, 1, 1, and then we will add it up. Remember, in computer, there is only one operation, that is addition. So that is why we use 2's complement. So whatever the number that is required to be added first needs to be converted to its 2's complementary negative form. Okay. Sir, can we add them, like take their denary and add? I told you that we cannot do that. We have to show answers as well as carries. So let's add it. So this will be 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2, 1 plus 1 plus 1, 3, 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2, and this one gets out. This is overflow. Okay. So this is overflow. Now we have to check what are these two numbers. 1, 2, 4, 8, 16, 32, 64, 63 minus 2. This is 61. And this one is 1, 2, 4, 8, 16, 32. This is minus 45. So what do we expect? A positive number. All right. What do we expect? A positive number. That is 16. Okay. So if you check it, this is 16 plus 16. So if you have a digit which is overflow, the scene is simple. What is that scene? If the expected answer is within the range. So what is the range? Range is from minus 128 to plus 127. Your expected answer was well within the range. So this overflow would not have any effect over your actual answer. But if the expected answer is out of the range, either greater than plus 27 or less than minus 128, in that case, this overflow means that you need more bits to accommodate your expected answer, since it requires more bits to get accommodated. In that case, since overflow bit is always chopped off, your answer will be wrong. So this is what your answer is, okay? So always perform this rough work. This slash is absolutely necessary so that your examiner would have an idea that whatever on the left of this slash is excess, overflow. Okay, Ria has created following logo as a vector graphic. So there will be a separate command for this, a separate command for this, a separate command for this. All right, so these commands are called what? Drawing list. In vector graphics, every single shape is made against a textual command. That is called what? Drawing list. And in that drawing list, when we define how big, how wide, how tall, color, border thickness. When we define all this, we define it with numbers, and these numbers in the drawing list, inside the drawing list, are called properties. Okay, so what are properties? Data inside drawing list about the shape. Example from the logo will be the border color, border thickness, shape, shape, not shape, color fill, etc. You don't have to write a lot. So what is drawing list? The textual command, to draw the shape on screen. Shapes are also called objects. I think objects is the better word. Okay. So what three shapes do we have? We have rectangle, we have triangle, we have text. Okay. Text as in R, capital letter R. So this is what we have to tell them. Remember in vector graphics, yes, Sufyan, only shapes, only geometrical shapes, only 2D geometrical shapes with it. In vector graphics, it is not saved as colors or pixels or resolutions or whatever. It is rather saved as the textual commands called drawing list. Having their property, system reads that command and obeys that command, creates that shape on the screen and all. Okay. So it is a bit strenuous for the microprocessor, unlike in what do we call them, bitmap graphics or raw graphics, where system only has to read few bits, determine the color and show it over the screen in a pixel. This vector graphic is whole different phenomena. Now, Ria takes photograph using a digital camera. The photograph is stored as bitmap image. Describe two differences between a vector graphic and the bitmap image. First of all, bitmap images are made up of pixels or colors stored for pixels. Vector graphics are stored as instructions or text instructions called list or drawing list. When bitmap is enlarged, it pixelates. When vector image is enlarged, it does not pixelate. Rather, properties are updated in drawing list. Okay. When bitmap size is increased by having more colors or pixels, file size increases. When vector image is increased, file size remains same.